So we are going to now explore various types of VT graph, their different shapes and what happens with each case. Okay, what kind of motion it represents. So first of all, if the graph is here, a graph is itself, this is the graph. Okay, exactly on the time axis. This, then what does it indicate? What does it indicate? Object is at rest. Why so? Because velocity is always zero, right? This would mean velocity is always zero, object is at rest. No motion going on basically. Object is always at rest. Please write it down. Object is always at rest. Okay. So that's the first. Second. Please draw it quickly. So let's say this is a horizontal line like this. Okay, over here. What's your conclusion based on this graph? Just by looking at this graph, what different things come to your mind? There could be more than one correct answers. There are so many things to talk about. Yes, Priya? Louder.
Object moves in a straight line.
Priya, આખો chapter જ એનો છે. Object moves in a straight line, isn't it? In every case, we are talking about object moving in a straight line. Then anything else?
Velocity is zero.
Velocity is zero. Who agrees with that interpretation? Right? Hiral, what do you want to say?
Velocity is constant, and if we go tangent, then acceleration is zero.
Velocity is constant. It would be zero velocity real if it would be here, because this is a VT graph. Understood? So, for example, I am not saying that you need to write a value, just for explaining. Suppose this is 5 meter per second value, then that would mean at any point of time the velocity of the object is always 5. Is that clear? So the velocity is constant. Did you get that?
Yes.
Yes or no? The velocity is constant. Alright? So velocity is constant. And what did you say here? Acceleration is zero. Obviously, if velocity is constant at any point of time, then acceleration would be zero. Simple. Is this clear?
Yes.
Everyone got it?
Yes.
Okay. One more thing. Velocity is constant, and then is velocity positive or negative?
Positive.
How do we know? Because it's on the positive side of zero. Normally, when we draw a graph, we take upwards positive. Correct or not? In the graph. So velocity is constant and positive. So object would be moving in which direction? Positive side. That would be toward. Generally, we take it towards the right side. Is it fine?
Yes.
Okay. What is this kind of motion called? What is this kind of motion called? So I was asking you, if velocity is constant, acceleration is zero, what kind of motion is that called? Raise your hand. What kind of motion is that called? Okay, yes, love?
Uniform motion.
Uniform motion. Who agrees? Who disagrees? Who has something else to say? Alright, Pragati?
Uniformly accelerated.
Uniformly accelerated motion. Himakshi? Same as what?
Uniform accelerated motion.
Uniformly accelerated motion. Okay. Sit down everyone. This is uniform motion. What is meaning of uniform motion? Velocity is constant. That itself is the meaning. Uniformly accelerated motion means acceleration is there and acceleration is constant. Yes or no?
Yes.
Sure, everyone got that?
Yes.
Uniformly accelerated motion. What is the meaning of accelerated motion? The object has some acceleration and the velocity will not remain constant. Understood? So this is uniform motion, and you can also describe this as uniform velocity, because uniform velocity and uniform motion always happen together. They are, frankly, in language of physics, they are synonyms. You understand what are synonyms? Yes or no? Means exactly the same. No difference between saying uniform velocity, that is object has uniform velocity, or saying motion is uniform. Both give this the same thing. Alright? Sure, no confusion?
No.
Uniformly accelerated motion means there is a constant acceleration and the velocity is changing. But this one doesn't have that. Right? Let's go to the next one. Easy case. So suppose this is a horizontal over here. Then what is your conclusion about this thing? Tell me whatever comes to your mind. Yes, Ariba, we'll start with you.
Sir, area below the axis, so it will be, velocity will be negative.
Velocity will be negative. Got that right? Anything else?
It is uniformly accelerated. No,
It is uniformly accelerated motion.
uniform motion.
It is uniform motion. Okay. So we are saying that this is uniform motion. Now how do you know it is uniform motion? How do you know it is uniform motion? Or why is it uniform? Okay, no problem. Well tried. Would others like to contribute? Okay. Yes, Hetvi.
So velocity is constant, therefore.
Velocity is constant. Sure?
Yes.
Everyone gets that?
Yes.
Velocity is constant and it is negative, of course. What Ariba said. And it is negative. The velocity is negative. So object must be moving towards the negative side. Correct or not? Object must be moving towards the negative side. Okay. Anything else that comes to your mind? The two of you. Anything else that you want to say? Acceleration is zero. Right or not?
Yes.
Acceleration is zero. Velocity is uniform, so or constant, so acceleration must be
Zero.
Anything else? So this motion with uniform velocity, alright, it's called uniform motion. It has got constant velocity. The velocity is negative, and the acceleration is
Zero.
alright.
Yes.
Anything that you want to add? Anything that others may want to add to this? How it was also the same. Only difference is the velocity will be negative. Clear?
Yes.
Okay, sit down. Well done. Clear? Let's go to the next. Number 4. Yes. So let's say this is a slanting line. Okay, this is still a line, of course, but like this. Then what does this kind of VT graph indicate? What does this kind of VT graph indicate? Yeah. Yes, Prisha.
Acceleration is constant.
Acceleration is
Constant.
Constant. Correct. Acceleration is constant. Very good. Anything else? Yet together, good one. There's so much. Any other answers? There are more things to say, of course. Let's put it. Sama.
Velocity is increasing.
Velocity is increasing. Correct. That's right. Yes. So velocity is changing towards the positive side.
Positive.
Velocity is changing towards the
Positive.
positive side. Alright. Hemanthi?
Uniform, it is a uniform accelerated motion.
It is uniformly accelerated motion. Right or not?
Yes.
Uniformly accelerated motion. Finally, Hemanthi got it to the favorite type of motion. Right? She wanted to say this all the way from first one.
So, from 70 onwards.
From there to on. Okay, so we were discussing that here if you have a straight line VT graph, acceleration is constant, so the motion is uniformly accelerated motion, and velocity is increasing. That we can see from the graph. Gradually, as time passes, the value of velocity is going towards more and more positive. Correct or not?
Yes.
Frankly, instead of saying increasing, decreasing, what I rather like to describe it as it's changing towards positive. First, it was probably plus 2. Then after some time, it will become plus 4, plus 6. That is, it is changing towards the positive. Alright?
Yes.
Okay. Anything else that you can describe by looking at this graph? There are still more things that you can definitely write. Maybe minor might not be that important to you, but ultimately in some form it might be asked in some exam somewhere. Anything else that you can decide by looking at this graph, however simple it might be. Nothing out of ideas?
Yeah. Object is not dropped.
Object is
Not dropped.
not dropped.
Acceleration and average acceleration also.
You could say, of course, object is not dropped and all that, right? But then that would be very specific, right? Instead of saying what it is, we will not say what it is not. Like I can say, this is not the graph of Earth revolving around Sun. Okay, this is not the graph of a dog running on a street. You understand what I'm saying?
Yes.
Although it's fine, it's right, but then it wouldn't make a lot of sense. So Prisha is saying that average acceleration will be same as acceleration. So pacha mokli dida pura pada vagar. Okay, it's acceleration is constant, so acceleration is constant, so average acceleration is same as acceleration. Alright? But that ultimately comes from here. Anything else which is not mentioned over here? Anyone? Is acceleration positive or negative?
Positive.
How do you?
Slope.
Slope of the tangent to this graph will be positive, correct or not?
Yes.
We have another information. Acceleration is constant and positive. Did you understand? Actually, that is linked with this. The velocity will change towards the sign of acceleration. I hope you remember that sentence. Velocity always changes in the direction of acceleration, right? So acceleration positive, so velocity is also changing towards the positive side. Alright?
Yes.
Fine?
Yes.
Okay. Alright, let's draw the next one now. We'll draw a similar graph, but instead of slanting upwards, it would slant down. Draw it yourself. Draw it from the positive side. So, number 5. Let's say it's like this. Okay. Yes. And yes, the board. So here we have another one. What do you think we should write for this? Hurry up. Quickly, everyone. Yes, Siddharth. Velocity is decreasing. Again, instead of saying velocity is decreasing, I'd rather say it's changing towards the negative side. Right? Why am I not saying increasing, decreasing? There is a very good reason. I'll definitely explain it. Yes, Dia? Anything that you want to add?
Acceleration is constant and it's changing towards the negative side.
It is changing whose it?
Acceleration.
Acceleration. So, what's your statement again?
Acceleration is constant.
Acceleration is constant, okay.
And in negative side.
Acceleration is
Negative.
Acceleration is negative. Who agrees? He is saying acceleration is constant and Negative. Why is it negative?
Down.
The slope of that graph is downward. Correct or not? So slope of tangent will be negative. Alright, is there anything that you want to add? Correct. It is uniformly accelerated motion. That's true. Anything more?
Velocity decreases.
Actually, again, instead of saying decreases, changing towards negative. Anything else? Is that it? Sure? Okay. Sit down first. Now let's take it to the next level. Here is the object coming to rest at any point?
Yes.
Yes?
Yes.
Where is it? Describe it in words. See if you can. Describe it in words. Yes, Nandini? You tried it a little bit, I think so.
When time.
When?
Time.
When what?
When time is zero.
When time is zero. તો એ તો અહીંયા થાય ને time is zero. અહીંયા એને કેવી રીતે કહેવાય word? પેલા ગુજરાતીમાં ટ્રાય કરી લો, no problem. Is it so tough to describe? Even in Gujarati, is that tough? Is your mother tongue not Gujarati? It is. Then I don't think it should be that tough. Use any simple language that you can think of. Vishwa?
The line passing through the time axis.
The graph crosses or cuts or passes through the time axis. Yes or no?
Yes.
Okay, so this graph cuts this axis here. Alright?
Yes.
So at this point, the velocity will be
Zero.
Zero. Understood? I think you meant the same. Yes. So here the velocity is zero. Right? That means object is at
Rest.
rest. Okay? Sit down. So here the object is at rest at this point. Okay. Next question. Does the object change its direction of motion? Does the object change its direction of motion? Yes or no?
No.
No? Then it's moving towards which direction continuously? Towards positive or negative or right side or left side? Negative.
Yes.
Object is continuously moving towards the
Negative.
Yes or no?
Yes. Yes.
No. Who says yes?
Sir, am I coming?
Who says no? Alright. Yeah, Anli?
So, at above the time axis, it is moving in negative side, and down the
Below the axis, yeah.
below axis, that is retardation.
But the question is it moving in the same direction? Is it moving continuously in the negative direction? Is the object moving continuously in the negative direction? Yes? I am not asking about acceleration, retardation, anything. I am just asking about is the object moving continuously in the negative direction?
Yes.
Yes. Okay. So here is the yes. Yes, Raghav?
So when actually velocity is decreasing, but object is still moving right side. But when
Right side. Huh.
but when velocity is zero, when the object is at rest, after that retardation occurs and it moves in opposite direction.
What is meaning of retardation, Raghav?
Sorry sir, no retardation, but it goes to opposite
It
direction
moves in opposite direction. How did you come to know that?
because
हमने तो ना focus
velocity
करी
is negative.
Velocity is negative. So what?
So velocity indicates the direction of the object.
Direction of object. Direction of motion.
Direction of moving object.
Velocity indicates the direction of motion. Yes or no?
Yes.
So He has said it right actually, but I'll just put it in more clear words. This part of the graph, here the velocity is positive or negative? Positive. Decreasing but positive. Is that clear? Positive. Is it clear? Here the velocity is positive. So object is moving towards which side? Positive side. That might be right. No problem. Is it fine?
Yes.
But over here, the velocity is
Negative.
negative. So object is moving towards the
Negative side.
left side or negative side. Did it reverse its direction? No?
Yes.
Here it was moving towards the positive side. It stopped and then it started moving towards the negative side, that is towards the left side. Clear or not?
Yes.
Sure.
Yes.
First, over here positive velocity means going towards positive side. Over here negative velocity. Pachu આવ્યું ને? If the velocity is negative, object is moving in the negative direction. Got it or not?
Yes.
Again that sentence. મેં તમને નથી કીધું, તમે બહુ ભૂલી જશો. What's that? Object moving velocity. So here the velocity is positive, here the velocity is negative. That means the object has reversed its direction. Everything clear?
Yes.
Yes or no?
Yes.
Sit down, but well tried. Any queries? Sure, nothing? પછી ટેસ્ટ લેવાની છે ને તમારી based on all these graphs. ટેસ્ટ નું નામ તમને કેમ એ રીતે થઈ ગયું? Okay. So here the object is reversing direction over here. Correct or not?
Yes.
Sure.
Yes.
Okay. Next, does the object have retardation at any point of time? Does the object have retardation? Yes or no?
No.
Okay, let me just indicate this clearly. What we just concluded here: object moves towards which side? In this part, positive side. And here object moves towards. Is it clear? Okay, please write it. Halse?
Retardation will occur.
Retardation?
Will occur.
What do you think? મને કઈ ખબર ન પડી. Retardation
Will happen.
will
Happen.
happen. Retardation will occur.
Yes, sir.
Where? Raise your hand. Who says retardation will occur and is ready to answer where exactly in this graph did you see retardation going on? બીજા લોકો તો નથી દેખાતું, તમને કેમ એવું દેખાય? Are you all okay?
Yes.
All right. Chandru,
Sir, below the
below this point.
yes,
Here.
upper side.
Below કહેતો તો
Sir,
નંબર
upper side of
so here.
Yes.
Retardation is okay.
Yes.
Who agrees? Who disagrees? બાકી બધા so confused, is it? How do we know it is retardation? What's the basic meaning of retardation?
If
Speed should decrease. That's called retardation. And when will that happen?
If acceleration and velocity in the opposite side.
Correct. When acceleration and velocity are in opposite sides. So here, in this part, is velocity positive or negative?
Positive.
Acceleration?
Negative.
So retardation. Over here, velocity?
Negative.
Acceleration?
Negative.
Retardation?
No.
Understood?
Yes.
Sure?
Yes.
Everyone?
Yes.
Thank you, Ned. Cannot thank you.
Yes.
સમજાય ગયું બરાબર?
Yes.
Here slope is negative, so acceleration negative. But in this part, velocity is positive. Suppose our 10 હોય તો આ કંઈક 5 જેવો છે. So velocity is positive, but acceleration is negative. So retarded. But that's not the case here. Both are negative. Got it?
Yes.
Okay. So basically, if you imagine what graph is this like? This is actually the graph of an object that has been tossed up. Think about it. You throw it with some initial velocity, upwards positive. So it has positive velocity. But then gradually as time will pass, because of acceleration, the velocity will decrease, that is go towards zero. This point. What will happen then? What will happen then? Object will start moving downward, that is its direction has been reversed. The direction of motion is reversed. Did you understand it completely?
Yes.
Yes or no?
Yes.
Okay. Well, next. Suppose the VT graph is a curve like this. Let's suppose the VT graph is a curve like this. See, there are thousands of cases of graph that we can practice, right? So we'll keep ourselves limited to some of the basic ideas only. Alright? So here, can you describe something about motion? Velocity, acceleration, moving in which direction, slowing down, speeding up, etc. etc. Whatever comes to your mind, hurry up, come on. Lots of ways to answer here, right? And so many different correct answers also. Yes, Amma.
The velocity decreases.
Velocity is
Decreasing.
decreasing. Again, instead of
Changing
saying,
towards
yeah, I'd say velocity is changing towards the
Negative.
negative. Okay, anything else? You sit down. I'll give someone else try. Himanshi, you want to try? Come on, કરી પાછું નીચે. Thank you. રીત કહેવાનું હતું, બીજું કઈ નથી કહેવાનું. Yes, Diya.
Acceleration positive.
Acceleration is positive. Who agrees?
No, sir. It's
Acceleration positive or negative?
negative.
Who says negative? Who says positive? Why positive?
Because it is power shift.
Yes.
What happened? I see you all are more alert today. I was expecting that you would get convinced if she will say the reason that this is a ball shape and acceleration is positive. But you didn't, so I'm happy about that. So here, what's the acceleration? Positive or negative? Negative. Is that okay? Because in a VT graph, you can draw the tangent. So let's draw a tangent anywhere, maybe here. Look at the slope of the tangent. It's negative. That's why the acceleration is also negative. Is this uniformly accelerated motion?
No.
Who says no? Why? Who says no? And is ready to answer why? Okay, Millie, what's your answer?
Because the acceleration is not constant.
How do you know acceleration is not constant? What if it is constant?
It is not a straight line.
Graph is not a straight line. What if this would be a parabola? Suppose this would be a parabola. Then would acceleration be constant? If this would be a parabola, would acceleration be constant? Still not a constant. Acceleration would be positive. હમણાં તો વાત છે acceleration is negative. હવે પાછું એની પર dispute. Parabola.
Of XT graph.
For XT graph it should be parabola, but this is VT graph, so it doesn't apply. Okay, it was my attempt to confuse her. Don't worry. ટેસ્ટ કરતો તો એક્ઝામ માં આવું બધું થાય, પેપર આમ જ સેટ કરવાનું હોય, બરાબર ને? Every minor detail is to be extracted. So you are right, acceleration is not a constant. Sit down. That we can easily decide. Sit down. Well tried everyone. And her answer is right in fact. But it's just that if you draw a few tangents, you will realize, do all the tangents have same slope? No. So that's what she said. If the graph would be a straight line, then acceleration would be constant. Which graph should be a straight line? VT graph should be a straight line. Then acceleration is constant. But here, is this VT graph a straight line? No. So is acceleration constant? No. Is this uniformly accelerated motion? No. Then what is it called? It is called non-uniform or non-uniformly accelerated motion or non-uniform acceleration. So what is constant here? Is velocity constant? No. Is velocity constant? No. Is acceleration constant? No. Nothing is constant here. Is that okay?
Yes.
Fine. That's it. Let me take you to one more deeper level by looking at this graph. Can you tell me whether acceleration is increasing or decreasing? By looking at this graph, can you tell me whether acceleration is increasing or decreasing? એકદમ concept નો question છે કેટલું તમે સમજી ગયા છો ગ્રાફ નું એની પર જ છે. Is acceleration increasing or decreasing? હું રીઝન તો પૂછી જો એટલે એમને તો આ તો પણ બરાબર છે. ઓકે યસ નિમાક્ષી.
Acceleration is decreasing.
Acceleration is decreasing. Who agrees? Again, okay, just instead of using words decreasing, increasing, let's better say, is acceleration changing towards positive or is acceleration changing towards negative? Acceleration is changing, that's a fact, correct or not? It's not constant. Then is it gradually changing towards positive or gradually changing towards negative?
Positive.
Towards positive. Who agrees? Who disagrees? Okay, how did you come to know it's changing towards positive?
Here upper side it is negative, then it goes downwards and it's positive.
Where is it positive?
Below
Below the axis. But below the axis તો જતો જ નથી ગ્રાફ અહીંયા જ છે. Anyone else would like to try? Yes, Tama.
Sir, because at the upper side the slope is more negative, and as we go down, then the slope will be moving. The velocity acceleration would be moving towards the positive side.
Okay. Who understood? Right. Sit down. Correct reason. Well tried, Hemant. It's okay. अब मैं क्या सीखवाई थी तुमने? Acceleration decreasing, increasing. Right? This is what I always tell you. Once you learn something, then you should try to use it for some other case. Gradually, you will learn that automatically on your own. Sit down. Well tried. So, first of all, have a look here. First point. This is slope of tangent, right? Very negative. Correct or not?
Yes.
Second point. Less negative.
Yes.
Third point, even less negative. Agreed or not? Do you
Yes.
remember which has more negative slope out of these three tangents? 1, 2 or 3? One has more negative. So gradually 1, 2 and 3 becoming less negative. So from negative it's going towards less negative, means it's changing towards positive.
Positive.
It's like acceleration change from -10 to -3 to -1. Then it's gradually changing towards the
Positive.
positive. Did you understand?
Yes.
Yes or no?
Yes.
Sure?
Yes.
Okay. Fine. All the lessons have been learned. Time for a little test.
So,
Yes.
so what happens if
Continue. I'm listening. Yeah.
આપણે સર પહેલા જે ટેન્જન્ટ છે
Hmm.
એ મોર નેગેટિવ છે એની આપણે જે થર્ડ ટેન્જન્ટ છે બધું આગળ નેગેટિવ માં કરીએ ડ્રો આપણો ગ્રાફ તો એમાં ફર્સ્ટ ટેન્જન્ટ છે બધું એક નેગેટિવ હોઈ શકે.
Oh, no. Right? You know that. Got it? Sure? Huh?
આમાં સર આપણે હજી વધારે ફર્સ્ટ કરતા વધુ નેગેટિવ આપણને મળી શકે છે.
આ ગ્રાફ પણ આગળ શું છે એની પર ડિપેન્ડ કરે ને. If it's continuing like this, then you don't get it. If you get it like this, then it will become positive. Okay? You understood that?
Yes.
પછી આવું કરો તો થાય. Then here it will become
Negative.
more negative. Understood? But this is really a weird kind of non-uniformly accelerated motion. પહેલા acceleration decreased you, in the sense it's going towards zero and then it's changing once again and all this. It's a fairly complicated motion, right? Okay, fine. Possible તો બધું છે. Nature allows for all possibilities. You just have to think of how to achieve it. Right? For example, if someone says, can you talk about a case where you get a graph like this? Then I told you, toss the pen off. It would be an example of this graph. Correct or not?
Yes.
Like that, even this graph can be understood by an example. For example, something has more velocity, gradually the velocity will decrease. Then it will become nearly constant. And then once again velocity will decrease further. What would this be like? Something drops, touches here. So velocity becomes nearly constant. Then once again I let it fall. Make sense or not?
Yes.
When the velocity decreases, it goes towards the negative, then zero, then like that it will change again and again. Understood?
Yes.
So complicated types of motion can always be thought of, and then you can make different kinds of stuff, right? Okay, fine. So done. Let's take a test whether you have understood the graphs so far. So I'm going to give you some graph and I'm going to ask you a couple of questions. Okay. So suppose the VT graph is like this. Okay, VT graph is V shape. Okay, and object starts at 5 meter per second, and this is also 5 meter per second. Alright, this is at 1 second, this is at 2 seconds, this is at 3 seconds, and this is at 4 seconds. First question: how many times does the object reverse its direction of motion? How many times does the object reverse its direction of motion? How many times does the object reverse its direction of motion? For simplicity, you can start with some object somewhere and see how it would move. That might help. How many times does the object reverse its direction of motion? Why aren't others participating? I want everyone to try. ખોટું પડે તો શું વાંધો છે? એક શીખવા તો મળશે જ. કન્ફ્યુઝન તો રહેવાનું છે. તો એવા જ ક્વેશ્ચન હું પૂછું તમને કે તમને ખબર હશે. I don't ask you anything straightforward. Sidra, what's your answer?
3 times.
3 times. Who agrees? Who disagrees? Who has other answer? Not 3, something else. Okay. Yes, Zoya. 4. Who agrees? 4 times. Okay. Who has a different answer further? Love.
2 times.
Hurt.
2 times.
2 times. Who else gets it 2 times? Any other answer? Yes?
1.
1 time. Who agrees? By the way, bucket name. Okay, so we have got all options 4 and 3 and 2 and 1. 0? Anyone? 0? Right? 0? I feel bad for 0. Okay, well, the answer is 2 times. Twice, 2 times it will reverse its direction. Who is saying yes? Okay, not the AC that is. Yes, Hiral, when?
When first one.
At what time?
Time at 1 second.
1. And second time?
Second.
Second time at second. That is, she is saying that it reverses at t equal to 1 and t equal to 2. Yes? No? No? Who says no? Yes, Jay?
3 times.
3 times. એવું નથી. He might still be saying 3. Which 3 then?
At 1 second, 2 second, and 3 second.
Okay, at 1 second, 2 second and 3 second. Yes, Himakshi.
At 1 and 3 seconds.
At 1 and 3 seconds. Not at 2 seconds?
No.
Sit down. Everyone. Well tried. The correct answer is twice. Reverse is twice at 1 second and at 3 seconds. How do we know? Before 1 second, the velocity was positive, so it was moving towards positive second, right side. After 1 second, the velocity becomes negative, so it's moving towards the left side, the right side, but the left side. Reverse? Yes or no?
Yes.
Direction, reverse. Correct?
Yes.
At 2 seconds, before 2 seconds, the velocity was negative. After 2 seconds also, the velocity is negative. So is there a reversal? No, આમ જ જાય છે. પહેલા આમ જ જાય. Is that called reversing?
No.
Understood? Why 2 seconds is not the answer? Before 2 seconds here, the velocity is negative. After 2 seconds over here, the velocity is still negative. That's why not reversing. But at 3 seconds,
Reverse.
before 3 seconds, you are moving towards left side.
Left side.
But after 3 seconds, it moves towards the
Right
right
side.
side. પહેલા આમ જતું આમ આવ્યું, પછી આમ. That means it has reversed twice. I hope you got that.
Yes, sir.
Once at 1 second and second time at 3 seconds. Okay. Next question. When is it in retardation? When is the object in retardation? How is this? When is the object in retardation? Between what time to what time? Okay, you answer up. When is it in retardation? Yes, he is. I don't want time. I want time interval. That is from which time to which time is it in retardation? From 1 second to 2 seconds it is in retardation. Anywhere else? From 1 second to 2 seconds and from 2 seconds to 3 seconds. Who agrees? Why do you want to change your answer? Because you want no support? Don't behave like politicians. Yeah. Anyways, what's your new answer? Above the axis. So below the axis it will be retardation. You didn't change your answer. Okay, Nandini? 0 to 1 second there is retardation. How do you know?
Because acceleration is negative. And
Yes, slope of the graph is negative, isn't it? So 0 to 1 retardation, and then 2 to 3 there is retardation. Sure.
Acceleration is positive.
Sure, 2 to 3. Why?
Acceleration is positive and velocity is negative.
Correct. 0 to 1 there is retardation because velocity is positive, acceleration is negative. And 2 to 3 there is retardation because velocity is positive. Yeah, you are right. Velocity is negative and acceleration is positive. Is that okay?
Yes.
Sure?
Yes.
Choose you. Masti.
You have given the statement that negative acceleration does not mean retardation.
Exactly. So
how it is possible?
turn on the fan, please. Then only I am going to answer. So I have this is an interesting point in this debate. You can pack your bag, but please listen to what I am saying. Okay. So she is saying negative acceleration does not mean retardation. Correct or not? So now I am sure her question is that here the acceleration is negative. Then why are you calling it retardation? Can anyone answer that? Can anyone help me here? Her question is, here the acceleration is negative. But earlier I have made you write that negative acceleration does not mean retardation. And yet I am saying that this is retardation. Okay, that means I am contradicting myself. Right? Okay, I am not worthy of teaching physics. Mazak karjo. All these statements are just like that. She hasn't said anything like that. Okay, who would like to help me? Alright. Yes, Prisha, what's your answer? Say it louder and Hasti, please listen.
At that same time, velocity is positive, so both velocity and acceleration are in different directions, so it will be retarded.
You didn't understand? Try better. Come on.
Velocity is positive, but at the same time, acceleration is negative. So it would be retardation.
Retardation is when velocity and acceleration are in opposite. It has nothing to do with positive or negative. Just two things should be opposite. So here velocity is in one direction, that's positive, and acceleration is are they opposite? It's retardation. Okay, what I have made you write does not mean that if acceleration is negative, we cannot have retardation. What I have made you write only means that just saying acceleration is negative, just saying acceleration is negative does not mean retardation. Understood or not clear? खाली negative acceleration थी retardation नहीं होता है. समझाओ? पक्को ने? For example here 1 to 2 acceleration is negative, but still that's not retardation. But here 0 to 1 velocity is positive and acceleration is negative, so it's retardation. Got it? Fine. Everything clear? Okay. Turn it off.